So welcome everybody. Welcome back to the Social Simulation Week. I hope you had a nice, good learning day. I see that we are now 72 participants in this first invited talk of the week. I am Melania Boritz and I am from the University of Tromsø, the Arctic University of Norway in Norway. And it's my pleasure to chair the session of Maja Schlüter from Stockholm Resilience Center at the University of Stockholm in Sweden. Maja is professor in sustainability and she's going to talk today about theorizing on social ecological phenomena through collaborative modeling. Her talk will be 45 minutes and we'll have enough time at the end for questions and answers. I'm supposed to be the co-host of the session, so in theory, I'm supposed to help if with any technical issues that might come up. I hope nothing will come up. But anyway, Maja, the virtual floor is yours.
Thank you, Melania. Thank you for the introduction, and also thank you to Flaminio and Eva for inviting me to give this talk. It's really a great honor to talk at the virtual social simulation conference or week, right? So I'd like to talk about a methodology for theorizing about social ecological phenomena such as regime shifts or sustainable natural resource use, or more particularly about using agent-based modeling in a collaborative process to develop explanations about how a phenomena such as a sustainable resource management was brought about. The ideas I'm presenting here are the result of collaborative work of a whole group of people that are rooted in modeling of different types. So next to agent-based modeling, also dynamical systems modeling, but also qualitative and quantitative empirical research and philosophy. Some of which may be quite familiar to many of you, such as non-environments, for example. So I want to highlight in my talk today kind of three opportunities I see in using agent-based modeling for developing theory, explanations and theory of social ecological phenomena. And each individual of them is probably well familiar to most of you, but their combination, in particular their use as part of an iterative and collaborative process that really starts from empirics, goes to theory and back in kind of an abductive process to better understand social ecological phenomena, is hopefully something new and interesting. I'm trying to see at least somebody here. All right, sorry. So the three potentials I want to highlight is the potential of ABMs to develop generative explanations to really help us to reason about how a phenomena could have been brought about, but also its use as a virtual laboratory for experimentation to better understand causal processes, to do counterfactual analysis. So what would have happened if something would have been different, but also to look at multiple explanations of a phenomena through, for example, comparing different model structures. And the third one is the potential and the use of ABMs as a boundary object to kind of help us communicate and make explicit multiple views and to integrate or compare across disciplines. So just a brief outline, I'm going to briefly say something about theory development in social ecological systems research and give a tiny little review of the use of agent-based modeling for developing explanations and theory across various disciplines. And then focus most of my talk on kind of presenting that methodology, illustrating it with an example from Fisheries first, and then provide another example also from Fisheries, actually. I like fish. And conclude with some final reflections. So why theory and what kind of theories? So the field of CES research has really matured in the last decades and developed a really rich empirical knowledge base. However, it's often quite descriptive and very place-based. So there's very interesting narratives. So for example, the transformation of fisheries governance in Chile after the breakup, or after the end of the Pinochet regime. However, there's a lack of theories in social ecological systems research. We often use disciplinary theories to explain particular aspects of the phenomena, but these disciplinary theories don't always necessarily align with the social ecological systems worldview. And finally, as more and more people are pointing out, actually in the literature in the recent few years, is the need for better understanding of causation in these complex systems, and understanding of mechanisms and causal processes, both for a better understanding, but also for improved policy and to find entry points for improved governance. So for me, causal explanations are really a first step towards middle range theories. So theories, the aim is not to develop any grand theories, but it's something in between the grand theories and kind of everyday working hypotheses you develop in a case. As Merton, the kind of founder of that idea of middle range theories in sociology, kind of has put it in the 1950s. Patrick Mayfreud has very nicely termed kind of the term of contextualized generalizations as a way to talk about middle range theory. So it's really about generalizations or theories that explain a well-bounded range of phenomena, not every phenomena, not across every kind of situation. But that theory also includes the conditions that trigger, enable, or prevent a mechanism or a causal chain. So the context within which theory actually applies. So when we think about explanations in theory and social ecological systems research, we're faced with many challenges, many of which I think are familiar from those that study social systems. The first one being the challenge of complexity. Social ecological systems are constituted through relations, so we need to account for these multiple relations. They're continuously changing, so we actually should focus maybe more on out of equilibrium dynamics than equilibria. They're characterized by complex causation, emergence, so there's no linear or rarely linear cause and effect relationships. The interplay of structure and agency matters, so we can't focus just on structure, just on agency as kind of an explanatory factor. They're radically open, so it's difficult to draw system boundaries, and we need to draw system boundaries when we model them. They're context dependent, which of course poses many difficulties for or challenges for generalization. Social ecological systems, and that's different from social systems, are also constituted through social and ecological processes, co-constituted. So we deal with systems where we cannot actually separate between what is social and what is ecological, but need to understand them through that interplay. And finally, as a result maybe of the complexity, also a part of it is that we have multiple explanations for phenomena. And these multiple explanations can both be a result of different perspectives. It's an interdisciplinary field, so we naturally have different perspectives that look at these systems, but also, of course, because of equifinality, that this phenomena can be brought about by different pathways or explanations. So we see social ecological phenomena really as emergent from interactions between people and elements of ecosystems. So the explanation then basically must include the actors and their interactions. And the actors here can be both people, such as the fisher interacting with other fishery actors here to the left. I don't know if you can see my mouse. For example, to develop fisheries regulations, but also the interactions, which are really at the core, the interactions between people and ecosystems, such as the fisher with the targeted fish stock, and interactions between elements of the ecosystem or biophysical systems, such as the fish species and its prey. And then these interactions together basically bring about the phenomena. So in order to capture that and kind of as an analytical framework to work with that, we developed a framework that is based on Ostrom's concept of an action situation, which is, in her case, a social interaction context that through the interactions produces emergent outcomes. But we expanded by saying there's also social actions. No, there's next to the social action situations, there's also social ecological action situations and ecological action situation. And a hypothesis or a possible explanation about an emergent phenomena would then be basically a combination or a network of key action situations of these three types that influence each other through their emergent outcomes, such as the outcome of a rule-making action situation, a social action situation, would affect how fishers can fish in a social ecological action situation. And just to briefly illustrate that with one example, if you look at the collapse of the Baltic cod as an emergent phenomena, which has been studied quite extensively, we understand, or ecologists would understand, the collapse as kind of a regime shift between from a cod-dominated to sprat-dominated state. That was basically triggered through changes in temperature and salinity, but also fishing pressure. However, when we take a social ecological perspective, fishing pressure, of course, can, but doesn't have to be adaptive to the actual situation in the Baltic. And it happened to be that before the collapse happened, there was actually a boom of cod, and there was a perception of a massive abundance of fish that just need to be people just need to get out there and catch them and kind of benefit from this huge abundance of cod. And of course, that perception changed much slower than the actual status of the fish stocks or fish populations once we were moving towards the collapse. And that perception also attracted immigration from West Coast fishers because they heard that there was so much cod to fish. It led to policymaking, particularly to subsidies to enable fishers to really benefit from this boom. It also influenced market dynamics. And we actually developed this explanation in an interdisciplinary group of empirical Baltic Sea researchers, and then implemented that in a model and analyzed these interactions, and found out that before and after the collapse, basically, and found out that the social interactions depicted to the left here actually stabilized an ecological system that was already starting to tip at the beginning, until kind of the rigidity of the social system, particularly the fact, so the stabilization came through a reduction of fishing pressure because the West Coast fishers left again, but then kind of there was no more adaptation and the system finally collapsed. So the ingredients when we want to develop explanations of social ecological phenomena are that they should be social ecological. People are really embedded in social and biophysical environments. They, through their actions, shape the environment, and the environment shapes their actions. It should be complexity-based, account for emergence, but also for dynamics, for path-dependent processes and feedbacks, micro, macro, and for context. It should be integrative and pluralistic, and build and integrate multiple understandings, and really be empirically grounded. So depart from an empirically observed phenomena and empirically develop possible explanations. So naturally, such an approach would be interdisciplinary and use multiple methods. It should be collaborative to really provide space for engagement of people with different understandings, and it's very important that it's explicit and transparent. Many of these challenges, or let's say the other way around, ABM, I think, is one of the few tools that actually can meet the challenges of complexity and also intertwinedness that I outlined before. And of course, we're not the first ones that have made that claim, but there's actually over the last maybe 10, 15 years, the idea of using agent-based models or modeling for explanation and theory building has popped up across many different disciplines that use agent-based modeling, and they all stress a little bit different potentials or advantages of doing that. There's ecology, and this table is really just a little glimpse and in no way comprehensive. Just to give a little bit of an overview. Ecology emphasizes the ability of ABM to integrate knowledge, particularly also qualitative and quantitative, to be used as virtual laboratories, but it also highlights the difficulty of or challenge of validation. Economics coming from a strong theory-driven kind of approach and theoretical, really highlights the improved explanatory power by having more realism, by being able to compare directly to empirical situations, but also the flexibility of the framework to encompass different meta-theoretical foundations, but highlights that it needs triangulation with other methods. Analytical sociology, not surprisingly, emphasizes generative explanation and the micro-macro links and the connection to empirical data. Similarly, as psychology and social simulation also stresses kind of the ability to look at interactions across levels and also temporal scales, and looking at human behavior situated in context. Difficulties are to really untangle the processes that produce the phenomena and to find a good balance between simplicity and complexity. And also something that we encounter when we work with empirical social scientists quite often, the difficulty to switch perspective from a more variable-based modeling and perspective to really agents and interactions. So after this brief kind of rush through the different works and activities that have inspired what we do, I want to now kind of go through the methodology. So it was really inspired and builds on what I just presented, these different experiences in the different fields, particularly also on the mechanism-based approach and analytical sociology. And the core of it kind of is an iterative cycle of identifying possible explanations in the field or through empirical research, testing and unpacking it through agent-based modeling, and then going back and validating and refining it in the field. So it builds on multiple methods, starting from case synthesis or in-depth case studies to identify the phenomena and develop the explanation, to the main step 2, the main part where agent-based modeling comes in and testing and exploring the possible explanation, validating it to come up with plausible explanations, approaches that can generate a lot of novel questions to go back to the empirical phenomena. And as I said, all of this in a collaborative process where collaboration really goes through all those steps from, and that with this I mean collaboration between the modelers and the non-modelers, but also of course within the community of experts from different backgrounds and disciplines, from collecting and integrating the diverse knowledge to assessing the possible explanations, reflecting on the findings, and really designing novel empirical research. So just briefly, how this is different maybe from other common uses of agent-based modeling that are particularly common in socio-ecological systems research, such as the use of ABM for policy analysis or to understand the evolution of a social ecological system under the effect of climate change impacts, for example, is that the models I'm talking about are neither empirical, so they're not case specific, but they're also not theoretical, but rather stylized based on empirical generalizations, something that goes towards a middle range theory. And the focus is really on developing and assessing and comparing model structure, and not on calibrating the model closely to an empirical setting and finding the right parameters. It's also, the key idea is to really open the black box of an IBM. So to understand the processes that are actually producing the macro level outcome we observe. Rather than generating a complex model or building a complex model and validating it with empirical data and then using it more or less as a tool to forecast possible implications of an intervention, but without necessarily focusing on what actually are the processes that brought about that particular outcome. Yes, and as I said, it's really about doing this in a collaborative way. Similar as we know it from participatory modeling, but with a different goal. Of course, the goal, rather than supporting action, the goal would be rather to develop explanation and theory. No, it's not advancing. Oh, there you go. So I want to illustrate this with two examples, but these examples are really also, or have been, instrumental for developing the procedure or the methodology. The first is the emergence of self-governance in small-scale fisheries in Mexico. And the second one I will come to later is the competition of interest groups, or the effects of the competition of interest groups in fisheries policymaking. So we now start with the first kind of step of identifying possible explanations. This is really about identifying the empirical phenomena of interest, collaboratively identifying either key factors or actors and actions or mechanisms or causal processes that may explain the phenomenon. What this explanation will look like will very much depend on whether it's about factors or actors and actions, will very much depend on the phenomena and who's involved in that process. And will, of course, influence later how we translate that into the structure of an ABM. Often these possible explanations would be developed either through synthesis or collection of empirical knowledge. Actually, the synthesis of empirical evidence is a topic or a theme that has attracted a lot of attention in the last few years in the CES community, in part, for example, but as a consequence of a synthesis center in the US, the Socio-Environmental Synthesis Center, which, for example, two papers looking at generalization or synthesis of empirical evidence come from there. Marioka et al. Published a paper 2 years ago, critically looking at generalized knowledge claims that have been developed or are developed from case studies, and how these claims should be, or they propose a framework to evaluate them and highlight the challenges also when we generalize from, or with these generalized knowledge claims, particularly the ones that have already been done and are published, in the sense of the context dependence, but also the bias in selection and the differences in methodologies and data sources used. So in our model so far, we've actually mainly really worked with the case experts, or with the experts of the phenomena to do the synthesis ourselves. There's also recent increasing interest in the qualitative data sharing and synthesis. And I'm sure the group that looks at quantitative and qualitative data in this social simulation week is looking into these issues. But then next to kind of synthesizing and generalizing from many case studies, there's also in sociology, again, from the mechanism-based school, the idea or the approach of mechanism-based theorizing that basically is based on individual cases, where the generalization is more based on theoretical ideas about social mechanisms. And the cases then can provide elements that can play a crucial role in causal narratives and causal explanations. This is an approach we used for the interest group competition example I'll present later. So there's multiple methods and ways of developing generalized understanding of the processes or the causal processes that might have brought about a phenomena, from using frameworks, quantitative meta-analysis, qualitative meta-analysis, longitudinal studies, qualitative comparative analysis, social or socio-ecological network analysis, so all those are more comparative or multiple N versus process tracing, which normally involves just a single case study. So with the example of, so now to the example of the emergence of self-governance in small-scale fisheries. This is work that was led by my then PhD student, Emilie Lindqvist, And we work together with Maja Schlüter, who has for at least 20 years studied small-scale fisheries in the Gulf of California in Mexico. And the empirical phenomena we were interested in is the observation that there's a dominance of patron-client relationships or arrangements between fishers and traders in the commercialization of the catch, or not only the commercialization, but everything that happens pre and post harvesting, over cooperative forms of self-governance, despite the fact that the government has been incentivizing cooperatives over the last couple of years. So we were interested in understanding why that is the case, why we see this dominance of patron-client relationships. We synthesized the evidence for that, or the possible explanations for that, using Ostrom's SES framework for explaining self-organization in common pool resource use, as kind of a theoretical framing to point us towards possible factors in that case that might influence the ability of these different organizational forms to self-organize. Comparative analysis of 12 fishing communities, but also analysis of primary field data, particularly interviews with fish buyers and fishers, and our collaboration with Javier throughout the entire process. And in some parts later on, when I come to the model building, really in kind of discussing assumptions that we make for formalizing certain processes. Just an example of the empirical data here to the right. This is both are graphs that kind of show on the x-axis how often the number of loans the fish buyer provides to fishers versus the number of times he or she actually gets the catch back. And what we can see with the fish buyers is that in many, many cases, the fish buyer provides a loan and actually does not get the catch back, while this pattern is completely opposite in cooperatives. So through the synthesis of this empirical data, we identified, not surprisingly, the importance of trust, which in this case we operationalize as loyalty, the loyalty of a fisher to his buyer or the cooperative, but also the trustworthiness of a fisher, which we operationalize as his reliability, that he really does what he says is going to do. So he goes out fishing when he receives the money and doesn't use the money for something else. These different dimensions of trust was what really came out in those analyses and in the interviews. However, we had no idea how these different dimensions of trust and also their dynamics actually interplay in favoring the survival of cooperatives or the survival of patron-client relationships, because both organizational forms have the issue of cheating, or struggle with the issue of cheating of a fisher not coming back with this, just by getting a loan from a fisher but selling the fish elsewhere. So as I said, the key factors for the survival of a fish buyer, a patron-client relationship or a co-op are related, of course, to the fish, the catch they can make, and the selling of that catch, either to the fisher makes the catch, either to the fish buyer or to the co-op. But whether the fisher cheats or not depends a lot on the trust that has been built up between the fish buyer or the cooperative and the fisher over time, which is what we conceptualize as the loyalty. So the higher the loyalty, the lower the probability of cheating. But also, as I said earlier, the reliability, which we operationalize as more as a property of the agent. The cooperatives are actually set with a set of fishers that they need to work with. They can't exchange them. The fish buyer can actually select fishers anew. This also explains the two graphs, the differences that we saw in the empirical data. And of course, the survival also depends on the dynamics of the fish population and the state of overfishing. So this was kind of the first step of developing the explanation, and now I briefly want to go into how it's been formalized in an ABM, and the structure and the processes. How we test then whether the ABM can actually grow the phenomena, so establish kind of generative validity. And then do experiments with the ABM to identify causal processes and mechanisms and the conditions under which they hold. So the structure of this ABM, or the key processes are that the fisher gets means for fishing, either from its cooperative or the fish buyer goes fishing, catches a certain amount of fish, sells that fish either to the cooperative or fish buyer that gave him the loan or to somebody else. And depending on whether that interaction is successful, he sells it to the same cooperative, loyalty will increase or otherwise decrease. Patron-client relationships or co-ops dissolve when they have no capital or no loyalty left, so then they would exit the fishery. So the setup of the model and kind of credibility checks is that if there's no cheating, we actually see that co-ops, and everybody has highest reliability, that co-ops survive better because they can establish more loyalty, and once there's overfishing, they won't necessarily go out of business as quick. If we introduce cheating and the loyalty growth rate is equal between the two organizational forms, we also see the co-ops perform better. However, if we have a slower loyalty growth rate for the co-ops, which is actually what corresponds to reality, because the co-ops are formal organizations, they need to be established formally. It takes much more effort and time to actually establish them. And that's one of the reasons, again, empirically found why they often collapse, is that they can't get over these transaction costs. So then under which conditions can cooperatives dominate the fishery? They can really only dominate the fishery. And now we look at, now that we've calibrated the model with these theoretical kind of reference scenarios, we now change both the heterogeneity in the distribution of reliability of the fishers from a low heterogeneity to a high heterogeneity with a high standard deviation. And differences in the initial loyalty a co-op actually has. We can see that they only dominate if they're very high initial loyalty, and thus can already buffer shocks. And also if the heterogeneity in reliability is not too high. However, this is in a stable environment, or let's say deterministic environment, with a deterministic growth rate and a deterministic catch. If we were that and have, for example, a seasonal environment where after half a year the catch reduces by 50%, we see that actually co-ops can thrive much better. And that is because they can build up loyalty during the good times that can then help them to survive the bad times, while the the patron-client relationships that exchange their fishers much quicker when they're unreliable cannot build up that loyalty. So this is what we can see here, why the fish stock is doing well, the co-ops can build up loyalty. And once the fish stock kind of decreases, the co-ops, the PCs, which are in blue here, basically start to collapse, while the co-ops that have made it that far can actually continue thriving and build up their loyalty. However, most of those co-ops actually go out of business right in the beginning. So they really need the opportunity to build up enough loyalty to survive these times of low resource availability. And the key mechanism underlying that is that they need to manage to shift the feedback from more cheating leads to less loyalty, leads to more cheating, into the opposite direction. That is less cheating leads to more loyalty, leads to less cheating, which then is kind of the mechanism that stabilizes the organizational form. So it's really an interplay of micro level, the initial loyalty and reliability a group has, the meso, the group composition, and no, the individual, the micro would be the build up of the loyalty, the meso, the group composition, and the macro level kind of setting in terms of resource scarcity and competition with other groups that then kind of determine when co-ops dominate and when PCs dominate. Formalizing the explanation, I just wanted to briefly reflect on a few challenges of translating this empirical explanation into an agent-based model and the tough choices that one needs to make when building the model and being confronted with the complexity. One is related to that. Of course, the explanation only highlights the key factors and interactions. But when we build an ABM, we of course need to build the world around it. So where do we draw system boundaries? What is included in a model and what not? And this is where the collaborative process is really essential, because it initiates kind of negotiations between the experts and the modelers on really justifying why something is included and why not, and kind of making transparent the assumptions and the strategies used to actually make them. So it gives us the possibility to deal with the normative implications of complexity. Basically the value-based choices that frame how we generate knowledge, and that we use kind of to reduce to be able to analyze the system and develop explanation. It's also quite challenging, as everybody knows, to avoid an overly complex model that we are then not able to really trace, kind of at least try to trace the causal processes. Just briefly about the validating and refining, that's certainly the point we can still invest and learn much more about. It starts with really collectively reflecting on those results and questioning whether the identified mechanisms like this feedback is actually empirically plausible, and going back to the field to see whether that is the case. But also, the whole process of developing the model has raised so many novel questions that already during the development of the structure of the model, Javier went back and his students went back into the field to kind of investigate other aspects. So it's a really iterative, or it was a really iterative process. So the insights we gained from this kind of process was the importance, not just of trust in general, which is of course very well known, but kind of more specific, the dynamics of trust, the heterogeneity of the reliability in the community, and the trade-off between flexibility and loyalty, the flexibility of a patron-client relationship to really select the most reliable members versus the ability of a cooperative to stick with the bad ones, but slowly build loyalty. And how that is really influenced through the environmental variability. So I'd like to present one other example. I see I'm already almost running out of time. I'll try to do that within the next 5 to 10 minutes. I think it's a really interesting example, so I would be very sad in missing it. So the second example is about interest group competition in fisheries policymaking, work that's been led by also my then PhD student, Kirill Orach, in collaboration with Andreas Duit from Political Sciences. And here we were really interested in an observation of many that study EU common fisheries policymaking, that in the 2013 policy reform, environmental interest groups were quite successful in bringing their interests and ideas into the reform. There were ideas related to bycatch regulation, for example. We were interested in how they managed, given that fisheries policy is very strongly dominated by industry interests. So why and how did environmental interest groups manage to introduce their ideas and preferences into the common fisheries policy reform, but then also use kind of that understanding to better understand when and how do interest groups influence fishery adaptation? Because we can really see different phenomena or different outcomes. We can see it's very often the case that strong industry interest groups kind of prevent adaptation of the fishery to environmental change, the decline of the fish population, for example, as we've seen in the cod collapse, for example, in the Baltic. But there's also the opposite examples where where interest groups actually enabled the adaptation or the development of new policies, and thus prevented the collapse, for example, in the toothfish fishery and the Southern Ocean. So when can we see which outcome? So this study started with an in-depth case study of the EU Common Fisheries Policy Reform using process tracing that identified coalition formation or coalition building as a mechanism, how environmental interest groups managed to influence the fisheries policy reform. But it also, that study not only identified coalition formation and the details or the different processes, how it influenced the policy reform process, but also the conditions under which actually that mechanism was successful. And the conditions, some of which are quite specific to the EU policy context. Others are quite general, like the certain degree of public attention to the policy issue was necessary, and that was actually in that case there. So based on that mechanism, we developed a model that kind of mimics quite stylized a policy process in a social ecological context. And modeling both environmental and industry interest groups. Both interest groups can engage in coalition building when they perceive a crisis. The industry interest groups perceive a crisis when the economy of the fishery goes down beyond a certain threshold. The environmental interest groups perceive a crisis when the fish population passes a certain threshold, fish population size. They engage either individually or as coalitions in lobbying. Lobbying influences the political position of the policymakers versus either increasing the quota or decreasing the quota, which is the policy measure we model. And we assume that the fishers follow the quota, so there's full compliance. And then we proceed to the next round. So there's industry and environmental interest groups. They form, both of them can form coalitions when they perceive a crisis or when they individually don't have enough resources to lobby because lobbying is costly. We also have set up the initial conditions that industry groups have twice the resources and the influence than environmental groups, basically reflecting the situation in many fisheries contexts. So if we have no coalitions, none of the interest groups can form coalitions, as we see here in A, and we see a collapse of the fish population in most cases because the industry groups will just push the quota higher and higher. There's a few cases where during the time frame of the simulation, they haven't quite completely collapsed. If we introduce coalitions, and note that both types of interest groups can form coalitions, so not just the environmental groups, we do see that the number of collapses is reduced. We get quite a high number of cases where there's a low fish population left, and some where they actually, the fish population stabilizes around maximum sustainable yield. So the intuition would be, yes, of course, now the environmental interest groups have more influence, and that's why we see better results. But when we now dig deeper, well, first of all, we think they probably produce more, they probably have more coalitions, right? Because they see that the fish population goes down. But if we analyze our results, we see that, yes, the environmental groups do form a little bit more coalitions, and it's more variable with the industry groups, but actually it's quite similar. And if we look at the influence that they have, so if there's no coalitions, we see that the industry groups have more influence. If they do form coalitions, the industry groups still have more influence. So just the fact that the environmental groups form coalitions and through that may have more influence doesn't explain the results, because they don't. So that kind of forced us to look a bit more close what's actually going on in the simulations. And what you can see here is basically 200 runs, and we can see what is color-coded, the individual representative runs color-coded is the collapse, what we can see. We see some runs that collapse very early, we see some runs that collapse much later, and we see some runs that stabilize. So then we started digging deeper And this is an example of one of the red ones that collapses very early. As we can see up here, this is the fish population size. It goes down to collapse. And we can see that the quota in the beginning is rather, so this would be the optimal quota, is rather at that level and only increases later when the fish population starts to decrease, which is the blue area here. We can see that at the beginning, there is a few industry coalitions and a few environmental coalitions, but there's not much activity. It spikes once the fish population starts to decrease. And we see that actually the environmental interest group coalition activity and influence only changes much later. At a point when the quota is so high that even, I mean, they managed to reduce the quota, but it's too late to prevent the collapse. If we now look at a case where they actually, the outcome stabilizes and the fish population is maintained at maximum sustainable yield, we can see that there's increase in quota rather early in the beginning, which alerts the environmental interest groups, which start their lobbying activities much earlier, which increases their influence earlier, which then kind of gets the attention of the industry interest groups. And we get these kind of tug of war dynamics where they basically pull and push whenever their crisis threshold is kind of, or their perception of the crisis is reached. And this tug of war kind of dynamic stabilizes the population. So the coalition formation mechanism increases the influence of environmental groups, but it does not so in the average. It is only successful in kind of supporting sustainable resource management when the timing is right, with respect to the dynamics of the ecosystem, so the state of the fish population and the policy system, so the level of the quota. And this tug of war dynamics that emerges is really critical for stabilizing the fish population. So through this kind of combination of the empirical in-depth study and the ABM, we could identify that mechanism through the case study and of course specifics of how it works, and then test the effect on the functioning of the mechanism through the model experiments and these tug of war dynamics and this path dependency. If an environmental interest group, and it's actually often the resource pool groups, if they start lobbying early enough, forming coalitions early enough, the system will stabilize. If that's not the case, the feedbacks within the ecological system basically bring it to collapse. So to summarize, I want to start with some of the pitfalls and struggles in trying to kind of go through such a process. One is that it really requires a shift in thinking about how empirical knowledge is used to construct models. So a focus away from using mainly quantitative data to parameterize models, to a focus on what are the narratives and what's the reasoning about causal pathways and possible explanations. And we've often struggled with that in working with empirical colleagues, in that they're very interested in working with the modelers, and then, but the main question is ask, what data do you need? I have this data, and we go like, not really the quantitative data we're interested in the first instance. We're interested in your understanding and the causal explanations and causal mechanisms or relationships, and that you hypothesize and how they're grounded in, or how and if they can be generalized or grounded in theory. It shifts the focus much more on model structure, and then which really kind of poses the very difficult questions of what to include and what to leave out. And these questions are of course not free from the perspectives we take, or the answers to these, the choices we make are not free from the perspectives we take. So the transparency about this process is incredibly important. It's not really straightforward to translate the empirical explanation into an ABM, and I think that's something that will be interesting to do more work on. And I think there's also a session on kind of a methodology to do that tomorrow. And of course, this process of co-development of an explanation and model is time consuming. All of those models took us several years, at least 3 years to develop in those processes. And they were, I mean, from the ideal picture I painted, they were of course still far away. I mean, the Baltic Sea model was a larger group, but often we worked with just one case expert, while of course it would be desirable or ideal to work with a whole group of an extended period of time. So to conclude, the use of agent-based modeling and an adaptive process for theorizing is really something that, or through facilitating a process of the ABM facilitates the process of analyzing, testing, and experimenting with empirical understanding of a phenomena, and is almost like a way to have a different perspective, a dynamic perspective, and a way of understanding these processes, interactions, and kind of transient dynamics that we will never be able to study in an empirical context. To help us unravel, or at least try to unravel, some of the causal processes. So to get to a mechanism-based explanation. And really this huge benefit of these modeling processes, that they help to support a reflective process of knowledge integration across disciplines or worldviews, and one that kind of accounts for the complexity and intertwinement of social ecological systems. And that's, with that, I want to conclude. That's it. A bit over time, sorry.
No problem. Thank you very much, Maja, for this very interesting presentation. So I will just give you a hand.
Thank you. Shall I stop sharing? Here? Probably, huh?
Sorry?
Shall I stop sharing, or do we need?
Maybe it's fine to leave the slides there if people have questions on specific slides.
Okay.
So now we have time for some questions. So let's see if anybody has questions.
Yes.
Yes, please, Francisco.
Yes, this is Francisco Navarro from Madrid. Maja, you have pointed out the importance of collaboration for eliciting the requirements or the data that you need. Could you be please more specific on how you build this collaborative environment in terms of your project? And also who are part of this collaboration? Who are the experts? How do you target these people?
Yes, that's a very good question. And in some ways, we might be a bit privileged at the Stockholm Resilience Center, because we have a lot of empirical researchers in fisheries, for example, at the Stockholm Resilience Center. So the Baltic model that I briefly mentioned in the beginning was really a collaboration between ecologists and social scientists within the Baltic Nest Institute at Stockholm University and the Stockholm Resilience Center. And there the collaboration was mainly in the form of workshops where we developed kind of conceptual models and possible explanations that then were translated by a postdoc into the model. And then we're back into next workshop kind of in discussing. For the other models, it's been mainly, or several other models, it's been mainly working with a few case experts, 2 or 3, and then having a lot of sessions from together analyzing the empirical data to really co-constructing the model together. So sitting there and this is how we represent that process. Do you agree or not, and why? Does that answer your question?
Yes, yes, thank you. But I guess you also have a high interest in collaboration or participation, because you want those users, I mean, that people to be the user of your model, right? Without them participating, maybe they are not going to buy the model. Is that your situation when you work on modeling?
I think that's very true for participatory modeling that aims to use the model to really develop suggestions for action or to support kind of action. In our case, the interest is more in developing explanations that are really grounded in empirical understanding and in bringing together expertise from different viewpoints, right? The ecological expertise with the social science expertise, for example. And mainly the interest of our empirical colleagues in participating in that process was in also the learning experience and learning and the integrative and learning kind of for the ecologists and learning more of the social scientist perspective on fisheries in the Baltic, for example. So it's not directly relevant for policymaking, I would say.
Okay, thanks.
We have one question in the chat from Bruce. How does one keep participatory knowledge and negotiation separate from more objective assessment of simulations?
Wait, where's my chat? Maybe, yeah, I'm trying to find my chat.
Easy.
I can read it. So very easy, as Bruce's questions are always. But can you just repeat it? I'm not finding it.
Okay, yeah, sure. I mean, often in these sort of projects, I'm thinking about my own experience here. You have a whole lot of knowledge coming from sort of participation and interaction with people, both experts and stakeholders. And then you get a stream of maybe external data. And my experience, certainly in my work, is that those become, after a while, very difficult to separate out. So you don't really know what's a viewpoint and what's validated, and it's a sort of mixture of them all, because you want to maximize the amount of information entering your model and being integrated. I don't know whether you have any experience of how we should maybe think about keeping those separate, or whether that doesn't matter, or what.
You mean particularly external data that weren't generated by the people involved and kind of the knowledge generated within that collaborative process?
Maybe, but often a lot of the data is generated by the people involved. You know?
Yeah.
there's
Well, that's the easier part, right? That's the data we want to work with, right? Because then at least the particular perspective that has informed that data can easily be made explicit and discussed. If it's data, of course, we also rely on data that comes from literature in many cases. And then I don't think there's a single answer to that. It really depends on what are you using the data for, in terms of, is it really the key part of your explanation, or is it some more, what do you say, peripheral processes that you need to include because your world needs to work as a world, right? If it would be for kind of the key explanation, I would always take those data into the collaboration and really discuss them and see what everybody's opinion is on what's included. But often it was really the discussions more about the narratives and the kind of causal assumptions we make and processes that were at the core than the particular data. If that makes sense.
Thank you.
I have a question, if I may, Melania.
Yes, please, Gary.
Yeah. So one of the things I've found when sort of trying to integrate knowledge and discuss it is that some researchers can be sort of a bit suspicious of it. So I suppose what I'd ask you is the question I get asked, and so I'm putting it to you, is what role does contestation have to play in this kind of process that you've outlined of trying to build these theoretical explanations of social ecological systems?
I think it plays a very important role, both in a reflective process, in thinking about the different possible explanations that we might have. Well, questioning the assumptions we make, right, in the first place. So I would always try, or something we're trying to do, is to actually be very sensitive to these contestations and not try to integrate right away, but rather use them as an opportunity to think critically. And ideally, and I have to admit that we haven't done that ourselves either, right? Ideally, that could lead to two different explanations. That way I always talked about them in plural, right? That we could then both put to the test and see what we learn.
I guess it's one of those things where there's probably not quite enough time to build all the different models you need to adequately capture it. But thank you for your answer. That's helpful. Thank you.
Thank you for your question, Gary. Are there any other questions? It seems that there are no.
I could add if you have highlighted some of the limitations of the AVM at the end of your presentation, and I would like to ask you if you have ever thought to make some hybridization of AVM with other hard or soft computing techniques that you think can be helpful when these type of problems arise.
So the only hybridization we have done so far is to combine an ABM or integrate an ABM with a system dynamics model, where we were interested in an ecological regime shift and trying to understand how a policy implementation process interacts with the dynamics of a shifting ecosystem, particularly the feedbacks and kind of the changes in basin of attraction. And since there is so much theoretical knowledge about an analysis of equation-based models of regime shifts, we integrated that with an agent-based model to also benefit from the analytical capacity we have in a dynamical systems model. We have not tried to combine it with any other methods yet, modeling methods.
Okay, thank you.
Yes, and we have one more question from Lisa. Lisa, maybe you can formulate your question yourself so I don't have to read it from the chat.
Shall I read it, or Lisa, are you going to?
Can you please maybe reformulate it so none of us has to read it, but just ask directly, please. Lisa? Okay, I can read it. So Lisa is asking, you mentioned equifinality. What role and how does the consideration of equifinality play in building mid-range theory?
Role, I don't know. It's a very prominent issue, right? I mean, in middle range theory, I think you would always accept that there is multiple explanations to a phenomena. There will always be multiple possible explanations. And you would move towards maybe one plausible explanation through then going to particular contexts or cases. So I think, or middle range theory acknowledges equifinality and sees it as a part of building middle range theory.
Okay, thank you, Maja. Lisa has problems with the microphone, so she actually.
No, I saw that.
Yes. I also have a question, Maja. I think it was the social simulation conference last year or 2 years ago, when somebody in the audience said, "Oh, there are so many models on fisheries. Why so?" So I would like to ask you. So why did you focus on fishing and fisheries?
Past dependence? I don't know. Well, in one part because these were the experts we could work with. So I had a collaboration. I established a collaboration with people working in Mexico on those small-scale fisheries, having many years. And I mean, it's a whole network of collaborators now. And that, of course, then triggers more collaborations. So I also have a background in marine ecology, but I don't think that actually plays a role. No, I've worked a lot on irrigation before. and we're now moving more to agriculture. But it's actually, I think, quite a pity that the communities, at least my impression is, that's communities modeling fisheries and the communities, the land use communities, are like land use modeling community using ABM, that there's not that much overlap. While there are many similar questions, like the question of human behavior is a question that's modeling human behavior is one that is now very prominent in both communities, but I don't see so much overlap, intersection of these communities.
And what would you say about the intersection or overlap with the with the fishery scientists? I mean, did you manage to present your models at the ICES conference, for example, or fisheries conferences?
Yeah, we've presented them at the MARE conference, which is more the social sciences and fisheries. Mm-hmm. We hope to present at ICES. We haven't presented at ICES yet. But we're particularly with respect to modeling human behavior, which of course is a central aspect. We're in quite close contact with the ICES, the special working group on that.
With the SID, I think it's called.
But one of my hopes is actually like for this role of partner-client relationships. We've worked now fisherman-trader relationships. We've worked a lot now in fisheries, and now one of my PhD students, Blanca Gonzalez, she's worked on that in fisheries and developed an ABM, which she will present, I think, on Thursday. In the second part of her PhD, and also with my work in my ERC projects, we want to move towards similar situations of smallholder farming and traders in agriculture systems, to study them and see kind of what are similarities and differences and how can we understand them.
So may I have a final question? If I don't know if it's final, but anyway, may I have a question? So my question is more related to, so you remember that one of the most main topics we were supposed to discuss in the social simulation conference was about gender, or how to improve women participation and inclusion in our community. What is your take on this? What do you think? What your personal story tells about, problems, advantages, or any kind of obstacles that a young woman might face taking this social simulation or agent-based modeling in general career?
Well, that's a big question. And you want a short answer?
You're fair. Yes. No, it's this is, I've missed this idea that we could probably have plenty of time in a social simulation conference to talk about this. And we were, as all the ESO members and manager committee, and were very, very, interested to, discuss about the debate about that. So it's a good chance to start a little bit.
So the obstacles for young women,
or any suggestion, maybe we see that I this morning when we were during the welcome to this event, I showed the gender rate of participants in this social simulation week. We are reaching 700 people, by the way, and the gender rate was not bad in the sense that we got 60% men and 40% non-men, and women and others. So considering the specificity of our community, which is typically, having to do with computing modeling and so on, it seems to be not a very unfair or rate, but we need to do more. And I would like to have your opinion about what can be done.
So maybe just to pick out of the many, many things that could be done and the many, many obstacles, pick one that relates a lot to my talk, is that what I'm proposing is really team-based science, right? It's a science that no individual can do on her own or his own. And my experience is that in that team-based science, it's often women, that's an opportunity, but also challenge, that are more engaged or more willing and open. But our scientific process often still not necessarily rewards team-based science, but one's individual leaders and individual contributions. In every PhD thesis, it needs to be very clear what the PhD student contributed. And we are lucky that in our field, it's acknowledged that because we're interdisciplinary, we need to work together in order to understand the systems we're studying. But in many, if somebody comes in from political sciences or from economics or from even philosophy, the requirements are very different. You need your first author individual, first author, we also need your papers where you're the sole author, that's what I wanted to say, right? And you're rewarded for your individual contributions and not for being member of a team.
Yeah, thank you.
Okay, are there any other questions? Okay, if not, maybe we can wrap it up here. Thank you very much for your talk, Maja, and I hope to see everybody tomorrow in the second day of the Social Simulation Week. We'll start at 8 o'clock Central European Summertime with a tutorial in data distribution of the Japanese synthesized population and real-scale social simulation. So thank you very much, everybody, and have a nice evening.
Thank you also
Bye-bye.
for listening.
Bye-bye.
Bye-bye.
Bye, thank you. See you tomorrow.
Bye-bye.